Bismillahirrahmanirrahim. Dear students, welcome to the course of Information Security. We are discussing lecture number 14, and the main topic of the lecture is software security. This is your teacher Tariq Aziz, lecturer at Institute of IT, Kohat University, HANGU-CAMPUS. So let's move on to the agenda. Dear students, in this second video lecture, we will discuss first of all some common security problems. Now, what's the aim, or we can say, what's the main aim of discussing these common security problems? The main aim is that to run through a number of different aspects of software design where security problems often occur. So we will look at common security problems with respect to design phase, or we can say with respect to the designing of the software where these security problems occur. So the first security problem is the access control issue. And dear students, we already discussed this issue in very detail in the previous lecture. So I would recommend that you should revise your concept. But let me highlight this once again here at this point. Okay, what is the access control issues? The first thing is that access control facilities, they vary greatly between different operating systems, and they are quite complex to implement and control. So that's why there is plenty of scope for programming errors relating to access control. This is the main reason. Now, dear students, we have to be careful about those files which hold access control information, and we must protect these files. So, ideally, any software accessing access control information, they should check the integrity of access control data. And number three, uh, care should be taken, or we have to be careful when implementing access control measures in software. If these measures are not implemented or not built into the operating system. Now, why we have to take care about these access control measures? Because there is a danger that these could be bypassed if they are not implemented, if they are not built into the operating system, if we directly develop or build them or implement them in the software. So they could be bypassed. So this is the danger. Now, dear students, the fourth thing is that we have to be careful with respect to writing software that calls commands such as those configured set user ID under Unix. Why? Because these commands they enable temporary super user rights. So if you write a software, let's say if you write a software and they call commands, which commands? These commands set user ID commands, because these commands they can be used to allocate temporarily super user rights. So if an attacker can compromise these super user rights, then it means he can do whatever he want to do, because with respect to Unix, we said that if user ID is equal to 0, then it means it's this user is now a super user. This user is now a root user, and he can do anything, whatever he want to do. Now, if you write software that call commands like this, and they assign user ID is equal to 0, or they can configure this user ID equal to 0, then it means that now this user is a super user, If hacker compromise this configuration or scenario, then he can do whatever he want to do. So we must take a special care about writing software, particularly with respect to these commands. Now, dear students, what's the fifth thing in operating system that use access control lists? And dear students, we already discussed about ACL, which is known as access control list. So in those operating systems which use these ACLs or access control lists, it is important to make sure that the impact of creating an object with a null access control list is fully understood. Let's say if you create an object and the access control list is null or with the null access control list, then there could be a problem. Why? Because at this stage it says that this has been a common source of vulnerabilities in operating systems such as Windows NT. So in Windows NT, this vulnerability is exploited, or we can say was exploited, or we can say that hacker can exploit this vulnerability, particularly with respect to Windows NT, because in Windows NT operating system you can create an object with null access control list. And what's the consequence? Hacker can compromise this vulnerability for his notorious actions or intentions. Now, dear students, the second thing is, or the second security problem is the privilege issues. Now, we already discussed about the principle of least privilege, and it says that only minimum privilege necessary to run a task should be allocated to any resource and particularly at a given time. Why? Because if you do not enforce the principle of least privilege, then the problem is that from software design perspective, one implication of this principle is that software should not be written in such a way that more privileges than necessary are required to run it. Otherwise, um, if there are more privileges, then definitely hacker can compromise these privileges, and correspondingly he can uh, benefit from his malicious intentions. Now, dear students, the other security problem is the buffer overflows. We already discussed buffer overflows in detail, so I would recommend that you should revise your concept. But let me explain the idea again here, that buffer overflows. This problem is related with respect to allocation of memory resources, and it's the allocation of memory resources which is probably the most common area where software security vulnerabilities arise. It means that with respect to utilization of memory resources, or we can say that the memory resource is the most common area where the security vulnerabilities arise. So, majority of these problems arise from buffer overflows. Because if we have vulnerabilities with respect to memory resource, so then definitely hacker can take benefit from buffer overflow, and consequently he can insert malicious code into the memory areas and fulfill his intentions. Now, dear students, the other security problem is the input handling. Okay, this is also related with the buffer overflow attack. And we said that with buffer overflows, memory resources are exploited when malicious data is pushed into a buffer. But there is another problem which is related to the input data, because when data is input, if the data is not valid, then consequently there will be a lot of problems. So that's why these researchers, one of them is the Howard. and the other one is leave blank. They stated two sayings, or we can say two maxims for handling input data. And what are these sayings? The first one is that all input is evil until it is proven safe. And the second saying is that data must be validated as it crosses the boundary between untrusted and trusted environments. Now, on the next slide, it says that those software developers who follow these two sayings, they are much more likely to produce secure code. Now, dear students, let's look at the meaning of validating data, or what do you mean by data validation? In general, there are three likely ways in which input data is invalid, and these are: the first one is bounds. So uh, here you have to check the bounds. If data is exceeding the specified bound, then there must be some sort of error that you are exceeding the limits. So with respect to bounds, it says that many pieces of input data lie between pre-specified bounds. So as an example, let's say we have 10 by 10 array. It means that the entries will be between 0 to 99. Okay. So if an attempt to address an array element using a number less than 0 or greater than 99 will result in out of bounds error or array index out of bound, because our limit is between 0 to 99. So if any number access the element less than 0 or the element greater than 99, then it means that this number is crossing the limits. So array out of bound errors, this should be generated, or an index out of bound error, this should be generated. Okay. Or we can say, in other words, that any integer used as an array index should be checked before it is used. Okay. Now, dear students, the second example is with respect to strings, and we know that string is treated as a fixed length array of characters in C language. Now, if an input string exceeds the size of the array, then a buffer overflow may occur, and consequently, malicious data can be inserted into the memory areas. So, therefore, all input string lengths, uh, dear students, therefore, if you input string, then their lengths should be checked before allocation to a fixed length variable. Sorry. Now, the other common security problem, which is known as types. So it is very clear that the data types should be checked. The type of the input data should always be checked. Why? Because there is a chance that if, or for example, this is an example, that if you don't check the types of the data, then what could happen? If the expected input is an integer, let's say, but the actual input data is a real number, then the software may have trouble interpreting the input data correctly, even if the input represented the same number, for example 12.0 instead of 12. Now here we are talking about the integer value, and we are talking about the float value or the real number, which contains the decimal, sorry, the decimal point. So here, in this case, this is the floating point value, and this is the integer value. Okay. Now, dear students, if you the expected input, let's say this is the expected input we want to. This is the expected input, but the user, what he do mistakenly or deliberately, he enter this input. Now there should be a type of mismatch error generated by the software, If there is no type mismatch error generated by the software, then the problem is that the software will interpret this input data correctly. Sorry, that the interpretation of the input data will not be correct, or the software may have some troubles. So that's why previously we discussed that if you want to write a code, then you should select your programming language wisely, because we talked about different programming language, and we said that Python and Java, they basically provide type safety checker, and they check these data types, and if there is any mismatch, they will generate error. So this particular security problem is with respect to types, that the input types should be checked for validity. Okay. Now, dear students, the next security problem is the error, which means that if your function return a value, then this value should always be checked for errors. Why? Because if these values are not checked for errors, and if your software calls a function and the function returns an unexpected value, then what will be the problem? The problem will be your program could continue inappropriately, or even your program could crash. So that's why if the function call return any value, then this value should be checked for errors to avoid any crash, or to avoid any inappropriate results. Okay. Now, dear students, the next issue is the naming convention. It is also a common source of software errors arises. Why? Because from unambiguous naming of objects and variables. Sometimes you have ambiguous names for your objects and variables, and these ambiguous names, they are also cause security problems. How? We can say that the same file on a computer system can be identified by different names, while the same name can be used for different files. This leads to many different types of problems. Now, dear students, at this point you may wonder that what are these problems? Let me clear this, that we will not go into the detail at this point. Only just it's enough for you people that naming convention is important, and you have to take care about the naming issues, because they also generate different security problems. But if you people are interested in detail, then I would suggest that you should search the internet for this. But at this point, it's sufficient for you people that you must take care of naming conventions too. Now, dear students, this was all about some security problems, some common security problems. Now, our next topic is sandboxing. Now, sandboxing is actually a technique to avoid security problems. Now, what is a sandbox, dear students? It's an isolated testing environment. It's a testing environment, but it's an isolated testing environment. And what users do with this environment, it enables users to run programs or to execute files without affecting the application, the system, or platform on which they run. So, software developers, they use sandboxes to test new programming code, but the cybersecurity professional, they use sandboxes to test potentially malicious software. So there are a lot of benefits of this sandboxing technique, and with the help of diagram, I will explain on the next slide that what do you mean exactly by the sandbox. If you look at the picture here, dear students, then here this first scenario is without any sandbox. So here we have our programs, and here we have our disk storage, permanent disk storage. Now these programs, they reads from this disk storage, and they writes to this disk storage directly. There is nothing between them, so it can cause security problems. But here in the second scenario, we have a sandbox in between these two entities. So here we have the programs again, and here we have our permanent disk storage. But now in this case, we have a sandbox in between them. So there are no direct reads from the permanent storage. Instead, the reads and writes operations are on the sandbox. And then accordingly, the sandbox will read from the permanent storage device. So this is a general concept of sandboxing. We can say big picture of sandboxing. Now, dear students, with respect to language, uh, which language support sandboxing? It says that sandboxing it is an important feature of Java programming language. Java programming language it supports the mechanism of sandboxing. And what's sandboxing in Java programming language? It is basically a program area and a set of rules that programmers need to use when creating Java code, such as applets, that is sent as part of a web page. So, if you are a Java programmer and if you want to develop Java code, or we can say if you want to develop Java applets, which is a program, small program, then you have to follow these set of rules. Okay, you have to follow the set of rules of sandboxing. What's the advantage now? The advantage is that before going into the advantage, let me let me explain a little bit about the Java applets. That what are the Java applets are small programs, as we said earlier, and these are sent automatically to the user's browser as part of the web page transmission. So, if the server, let's say this is the client and this is the server, and server wants to send some applets to the client side, or the server, if the server it wants to transmit some web page towards the client, then these applets will append with the web page and then will send automatically to the client side, to the client browser. Now, as soon as these applets arrive at the client browser, then it will execute it. Okay. So let's say this is the server and it sends some web page towards the client. Now the applet will append with this web page and then this web page will be sent towards the client. And when this web page arrives at this point at client side, then these applets will be executed automatically. Okay. So if you don't follow these rules of sandbox, then these applets may cause problems at this end, and the clients will suffer from security issues. Okay, so that's why it says that sandbox is a program area, or these are the set of rules which the programmers must follow in case these applets arrive here with the web page, so they can execute securely and it will not create problems for this client. Okay, so this is the basic phenomenon and we already discussed here. Now what the sandbox restrictions will do: the sandbox restrictions will strictly limit what system resources an applet program can request or access. So this is the big advantage. Now what the programmer have to do: essentially, the programmer must write code that plays only within the sandbox, not outside that. So we can say that the sandbox is a small area within your computer where an applet's code can play freely, but it's not allowed to play anywhere else. So we can say that, let's say this is your system, your computer system, and you specify this area as a sandbox. Now, if the applets arrive here at this stage, then they will play in this specific area, not here. Okay, so this is the advantage of sandboxing. So dear students, by using sandboxing, we can also secure ourselves. This is another technique of secure software development. Finally, we will discuss our last topic of today's lecture, which is known as control flow integrity. So, what is this? It is also known as CFI, or the complete name is the control flow integrity. And what's the basic concept? It's actually the behavioral based detection. And what's the basic concept? The basic concept is that we have to R. The CFI have to observe the program's behavior. Why? To check that is it doing what is intended to do, or it is crossing the limits. But if it is not intended, if it is not doing what it is intended to do, then it might be a compromise. So this is the basic concept. Now, dear students, what's the challenges? How we have to ensure the control flow integrity? For this purpose, first of all, we have to define the expected behavior, and how we will define this expected behavior by using the control flow graph, which is also known as CFG. What is this graph? It's a graph that covers all valid execution of the program. And if there is invalid execution, then program has to halt or stop executing. Now the second thing is detect deviation from expectation efficiently. If there is any deviation from the expected behavior, then you have to detect this efficiently. And who is responsible for this? For this purpose, inline reference monitor is used, which is also known as IRM. What this IRM will do, it will observe execution of the program or your process, and it will halt accordingly, or it will contain execution if the program is about to violate the security policy. Now, dear students, this last point is important, that why we need an inline reference monitor. If we want to implement the security policy, then it will be implemented through the IRM. Okay. Now, dear students, at a high level, what is control flow integrity, or CFI? It restricts the control flow of an application to valid execution traces. So it's a good mechanism, and by doing this, or by ensuring control flow integrity, an application, it will always, or we can say, uh, it will execute to valid state. Now, dear students, CFI enforces this property by monitoring the program at runtime. Okay, this point is basically about the working phenomenon of the CFI, that how CFI enforces this property by monitoring the program at runtime and comparing its state to a set of pre-computed valid states. If there is an invalid state detected, and an alert is raised, usually terminating the application. So this is the basic concept of CFI. Now, dear students, let me explain the concept with the help of the diagram. So so first of all, we have to define the expected behavior. Now, dear students, if you look at the diagram, then we have a couple of functions here, and these functions are calling some other functions, and then we have our return values. So we have a sort to function which accepts three arguments: the first array, integer array, the second integer array, and the length. Now this function called sort function. Okay, this sort function, it accepting three arguments: a array, length, and then it is calling the another function which is known as LT. So we are calling the sort function again with the arguments. At this time, it is calling the another function which is known as GT. So this is the LT function, which arrange elements of array in ascending order, and this is the GT function which sort or arrange the elements of array in descending order. So if you look at the picture, then this is a R sort2 function which calls this sort function. Now this sort function called the LT function, and this sort function also called the GT function. So this is the function call. Now dear students, if we uh, make the diagram more clear, then what will be the calls, or what are the calls and returns? So with the green arrows are calls, green arrows represent our calls, red arrows represent the returns. So sort2 function, it calls the sort function. Okay, this sort function then call the the LT function. Okay, then the return value from LT function is represented by this arrow, and then this value is returned to R. The result of this sort will return to this sort function, sort2 function. Okay, now sort2 function is again calling the sort function here, and this time this sort function calls the GT function here, and then the value is returned to sort function, and this value is then returned to sort2 function. So this is the calling and returning mechanism of this CFG. Okay, now dear students, bear in mind that CFI comply with the corresponding CFG, which means that CFG is very necessary for integrity, for control flow integrity. And when we have to compute this CFG, you can compute this CFG in advance. But when? During the compilation time or post compilation time, from the executables or from the binary. Now what this CFG will do, it will monitor the control flow of the program and ensures that it only follows paths allowed by the CFG. But here we have some observations, or you have to note something, that if you have direct calls in your program, then they need not be monitored. Why? Because we are assuming that the code is immutable and the target addresses cannot be changed. So then why we need this CFG? For what purpose? We need this CFG to monitor only indirect calls. The calls with respect to jump instruction, because jump instruction will interrupt normal flow of control. The calls with respect to call instruction, and with respect to return instruction. So if you have these types of instructions in your program, like jump instruction, call instruction, and return instruction, then these are indirect calls. So in this case, you can use the CFG to monitor these indirect calls, and these indirect calls, they usually involve registers. So to cut the story short, we have to monitor the indirect calls by CFG, or by using CFG we have to monitor the indirect calls. Okay. Now dear students, if you look at the diagram, let me explain the direct calls and indirect calls with the help of the diagram. This sort2 function, it is calling the sort function two times. Okay, the first time is here and the second time is here. So the orange arrows, they represent the direct call. So CFG are not used to monitor these calls, because these are the direct calls. Instead, CFG, they are used to monitor the indirect calls. And what are the indirect calls? The arrows with the red color, these are the indirect call. So sort function is calling sort to function. It is calling sort function, and then this sort function is calling the LT function and GT function, and then values return from here. This is the returning value, this is the returning value, and then this is the returning value, this is the returning value. So this is basically the indirect transfer or the indirect call. So CFG is basically used to monitor these indirect calls. Now, dear students, here the question is, if you want to implement an inline monitor as a program or transformation, then what we have to do? For this purpose, dear students, we have to use the labels. Now, where we have to insert these labels, insert a label just before the target address of an indirect transfer. And then we have to use the code. So insert code to check the label of the target at each indirect transfer. Abort if the label does not match. And the labels are determined by CFG. So let me explain this phenomenon with the help of a diagram here. What we did here, we mentioned the label now here at returning point and the indirect calls. With respect to indirect call, what we did, we used label. So label L, okay, and this is also label L, label L, label L, label L, because sort function is calling GT and LT, so label L, and correspondingly values will return from this GT and LT, so label L. Then where these values are returning at this stage, so label L. Then this value is returning here, so label L. This value is returning here, so label L. So what we did, we represented indirect calls with labels. We put labels here, okay. But this is a simple labeling, okay. Now, dear students, the problem is that if the return value is towards the intended destination, then okay, no problem, because this value is returned here. This value returns here, and value from this function also returns here, and also value from this function from sort function returns here, also returns here. If there is other call, if there is a call to system function, or if the value returned towards the system, then there will be no entry, okay, it will be blocked. Why? Because in CFG it is not mentioned that the return value will move on to some other place, like towards the system. That's why, as per the CFG, this call will be blocked. So this is the advantage of CFG. But dear students, with respect to this scenario, it is okay. But what if the adversary or the attacker, they manipulate the return value, and then the value return to this label L again? So it is okay. But with respect to program, the behavior of the program could be wrong, or or program could behave abnormally. So what we have to do then? Then in this case, we have to overcome this issue by putting some constraints. So we are putting these constraints here, that return sites from calls to sort must share a label L. Call targets to GT and LT must share a label M. And then we have unconstrained label, which is represented by M. So look at the labels here now. Sort function is calling the GT and LT functions, so we labeled them with M. And then the return value we label them to with N. And then these return values from sort to function is labeled with L. So now in this case, this entry, now in this case, what we did, we overcome the previous issue. This entry will not be allowed. But again, there is another issue. The issue is that this sort2 function can call this, and then the return value can go to some other site. So here it says that still permits call from site A to return to site B. Now we are calling the site A, but the value returns to site B. This option is still valid. But at this stage, now you people are familiar with the concept. Then you can insert some more labels are you can insert some more constraints to get rid of this phenomenon too. But at this stage, I hope that now it's clear to you people that what's the advantage of the CFG and how we enforce the control flow integrity in our software development process or in our software development. So this is all about the today's lecture. I hope that you people will understand. Now, dear students, let me summarize the lecture. Dear students, we discussed the security issues related to software. So basically, dear students, security issues arise in software designing phase, in software development phase, okay, or we can say in software deployment phase. So now we discussed first of all we discussed that sorry, what are the security principles. There are some security principles. If we follow these security principles, that then chances are that we will develop a secure software. We discussed some of the common security problems that like buffer overflow, privilege issues, etc., etc. And we discussed the boxing technique. That this is a technique to develop a secure software. And finally, we look at the control flow integrity mechanism, that it can also provide a good space to ensure security in software. Now, dear students, we also discussed some of the approaches which are not recommended with respect to software development. So I hope that you people will understand. If you have any questions, please put your questions on KCMS. Thank you so much.